G'day. I was thinking about making up a part for a drill press, and we'll come to that later on, but that got me thinking about circles and holes and how you measure them. I guess the difference is that when you've got a rectangular piece, you can measure a width or a depth or a height or something like that directly, and you can then machine to suit. When you're dealing with holes though, you usually need to know where the center is if you're going to be drilling or milling something to suit or boring to suit. And so this video is just about some of the methods I use for working out what size holes are. Some of the methods are pretty accurate, some of them are not, but it doesn't matter too much, as I'll show you a little bit later. The important thing is that you can work out what the holes you're looking at are. I said earlier on, in some cases it doesn't matter. And the reason for that is this. If you've got a fillet in a 90-degree angle and you want to work out what that radius actually is, a bit of trig says, well, if that's radius, that's a 45-45 triangle, so that's r on root 2, which means that that space there is 1 take r on root 2, is 1 take root 2 multiplied by r, which is that, which comes down to 0.293. So let's say 0.3 of the radius. If you've got a radius which you think it might be 10 millimeters, or it might be 3/8, 9.53 millimeters, the difference in those is 0.5. Okay? So doing a little bit of the maths, 0.5 by 0.3 is 0.15. So basically, the distance between those two radii is going to be 0.15 of a millimetre, which is going to be very hard to pick. So if it's just for a fillet or a dress thing, it really doesn't matter. I mean, there will be some difference because the quadrant points of the circles are in a very slightly different space, but the chances are that if it's just a fillet on a thing for smoothness, you really won't be able to pick the difference. So some of these methods will give you much better accuracy, get you much better the true value, but at the same time there'll be some of them where it won't matter. Starting with small holes, how can you measure them? If you've got a set of drills, such as these ones, these are number drills, then you can use those as a gauge of some sort. Okay, you've got to be careful you haven't got burred the shaft up, but that could work. If you go to fastener shops, they'll sell you these things, which are referred to as dowel pins, and once again you can do something similar with these and just try them for size. And that's another way. Typically dowels are a little bit undersized, but they're pretty darn close. They're ground, and so provided you've got the right size dowel, you can use that as a gauge for the pin, for the hole. The other alternative is something like these. These are gauge pins. This set is from 61 thou up to 250 thou, so 1/4 of an inch. And it becomes pretty simple to just walk your way along in increments of 1,000 or so, or until you get close. Something more, okay. And that way you can find out your hole. Sometimes you might have a larger radius, or you might have a radius which is incomplete and you want to know what that is. So there are a number of things that can be used for that. There are these things which are referred to as radius gauges. This is a bigger set here. These ones go up to 3/8 of an inch, and you use those by placing them on there. You can also do the inside of a circle or radius and check that out. Now, as you can see, there's a bit of a gap between the gauge and the part, so that isn't the radius. Another possibility is one of these. This is a drawing template or a circle template, sorry, from drawing. I used to use this when I was doing tech drawing, and it's a good way. It's not terribly precise, perhaps, but it's a good way of getting a rough idea. And so if you want to see what a radius is, well, you know, you can sort of see if you can line up with that. And that one there, it's still not quite right. The easy way to do that, of course, is just to measure across the flat. Oh, it's 50. How about that? These do go up to 50mm diameter circles, so you could do that. But I find this very handy if I'm trying to work out a radius, or if I'm trying to mark out a radius. If I want to know if I've got enough room there, I can use that and then run the scriber inside that to give me my radius. If you have a partial radius, don't overlook things like paint tins, because you can fit those into a radius and then measure that and say, well, that radius must be, you know, half that diameter if it's a good fit. I have a number of things that I use, and in fact I use things like paint tins when I have to put a radius on the corner of tabletops and things when I'm woodworking. I'll use a paint tin to just basically give me my radius. If you're after a precision measurement and you're not able to get some sort of calipers or whatever in the hole, or it may just be the uncertainty attached to a piece of measuring equipment like this, you want a more accurate measurement, and so instead of doing calipers, you might have to resort to something like this. I refer to these as telescopic gauges. I think there are other names for them. The way I've been taught to use these is basically you have them adjusted and lightly clamped on an angle like that. You then rock them over, and then you should be able to come along and measure that with a micrometer or something like that to work out what the diameter is. And that's 25.44, so I think it's probably safe to assume that that's a 1-inch bore. The one I prefer to use for this sort of thing is this one here, and that's simply because there I'm working against spring pressure, and so I can come along, zero that on the gauge, and I'll get, if I've got everything square, get a square U, 25.440. So I usually find when using these, and some people can get very accurate with these, but I usually find when I'm using these that I can be a couple of thou out. Another possibility is things like these. These are referred to as inside calipers, and once again you set them up and then you measure. Can be tricky trying to work out where the spring takes over. That I'm getting to about 4.4 on that. Once again, this will depend a lot on the condition of your equipment, the feel of the calipers, all that sort of stuff, but this is another way. So far I've shown methods for measuring holes which rely basically on a whole hole, or measuring fillets, radii, using gauges. Sometimes you haven't got a gauge that's big enough, sometimes you haven't got a full diameter where you can measure a diameter, whether it's inside or outside, and so you then have to resort to a few tricks, and the question is, well, how you do that? Well, I'll show you that now. So this is my mill. This is the power feed motor for the cross feeds, and as you can see here, I've got a bracket that I've made here to mount the DRO, and you can have a look at that and say, well, okay, that's probably a full diameter, but this will do for the illustration that we need here. So what I'm going to do first is use a profile gauge to work out, or to get something that I can then trace. Okay, so the nice thing about the profile gauge, it gives me an inside radius and an outside radius. Or sorry, it gives me a concave and a convex radius, so I can take my pick. I'll probably use the concave, I think. I have my radius. I'm now going to trace that onto a piece of card. Now, you could also use a sheet of metal with some blue applied and scribe your way through, but this is just a little bit easier for me because I haven't got a bit of sheet metal handy. I find the best card to use, this is a bit of cereal box. It's the only reason I buy Swiss chocolate is to get the card. Honestly, trust me on that one. The idea is that I'm going to get my profile and I'm going to use a pencil and I'm going to trace it like so. Right? So I've now got the radius that I'm chasing. The next bit is pretty straightforward. I'm going to use a compass here because that's why one of the reasons I thought a bit of card would be a good idea. And this is just a ratty school grade compass. It doesn't have to be anything terribly flash. To start with, I'm just going to draw an arc like that without changing things. Go to the other end of my radius, draw another arc. That line should go through the center of the circle. I can now come along and change that to the same thing on my center point and on the end point. Now, if I've held my mouth right, these should all go through that center line at the same spot. I can now come along and measure that, and that says 90. And so I could say, well, if I can set up a boring head now and bore that, or I can set up a part on a lathe and bore it to 180 diameter, and lo and behold, it fits. I find it's handy to write what these things are next to them, just in case you put it down overnight and come back and was that R90 or was it R85, because otherwise you've got to do the same thing. But there you go, that's a way of determining what the numeric value of a radius or a diameter is, so that you could then set it up on a mill or a drill to produce a form that follows your template. So I guess to recap, if you can measure things directly with a micrometer or a set of calipers, if they're accurate enough for you, then by all means do that. But if the holes are too small, you might need to use pin gauges, drill bits, that sort of thing. If the holes are too big, you may have to resort to telescopic gauges and that sort of thing, so you can then bring it back to something you can measure with. If it's a partial circle, hole, pin, whatever, then you have to use things like profile gauges, circle templates, all that sort of thing, and including some direct tracing of the radius. I hope that's been helpful to some people, and thanks to those who've inspired me in all this, and see what we come up with the next time.